Now let's look at a few case studies to see how it's really effective. The first one we have is from a petrochemical plant where we found a weak joint in a 33 kV cable. The first test we did on this particular cable was, like, as you can see, 310 meters, 3 core, was the VLF tan delta test. And we got very high tan delta values, especially in the B phase. You can see the values are way beyond the permissible limits. In order to find out, okay, we've got poor tan delta, there is a problem, there's water training, let's identify where is the defect. So we performed two tests, the damped AC partial discharge test and the LIRA test. The damped AC test was performed at 2 U0 or 40 kV, and it could not pick up anything interesting. As you can see from the partial discharge graph, the PD values are very low and these were only occurring at the termination. Next, we performed the LIRA test, and this is the actual results from the LIRA test. So you might see the signal over here at 288 meters. We were getting a very strong impedance change, and it was like, aha, we have a defect. The client actually excavated that section of 208 meters, and they found a joint there which was in bad condition. This joint was replaced and the measurements were repeated. Now you can see the tan delta values have become perfect, all are in the green zone, and we repeated LIRA and those very strong reflections at 288 meters have disappeared. So you have a condition where a fault was picked up using one technology, the location was determined by another technology, the fault was physically verified, repaired, and the repeated test results showed the efficacy of the repair, which is what we want. The second case study is at a lower voltage, it's a 4.2 kV cable, 1.3 kilometers in length. Now here what happened was we performed many traditional tests such as insulation resistance, VLF tan delta, and VLF partial discharge. The tan delta values were good. The partial discharge values, well, partial discharge didn't show anything. IR value was slightly, very slightly low for one particular cable. So the cables were put back in service, thinking, everything is fine. And 3 months later, one of the cables, the one which had slightly poor IR value, failed. And this was like a high resistance fault. The cable was still able to withstand 1 kV, and the traditional thumping methods couldn't find out the location. We went and performed LIRA tests and detected 3 weak spots. Since we wanted to further pinpoint which of these was the worst, what we did was we applied 1 kV, which is the maximum voltage the cable could sustain, for a period of 1 hour. And after that, we repeated the LIRA measurements. As you can see now, the signal reflection or the impedance change at the 1.1 kilometer location had drastically increased. So we know, okay, there are 3 big parts, but the weakest spot is at 1.1 kilometers. The client changed the section or replaced the section, and then the cable could be energized. So again, fault confirmation. Last case study was of a really long cable, a 13.5 kilometer long 22 kV subsea cable feeding this large offshore oil field, really old cables. Essentially what happened was, okay, the cable failed, one phase single core cable. There was a lack of redundancy, and this was again a high resistance fault. So the typical methods that they were used, that were being used, weren't able to pinpoint any defect location. We came in, performed LIRA, and we said, okay, the fault's at 3.77 kilometers. It was excavated, they found a joint at this particular location, replaced that, and the cable was put back in service. If you quickly look at the graphs, this is what were the LIRA signals on all the three cables. So on the first and the second phases, we were able to see the entire cable length, but we were getting very, very strong reflections or impedance changes at 3.7 kilometers. On the third phase, the one which had failed, the signals were unable to travel beyond 3.7 kilometers. So we knew, this is where the defect is. Just to quickly compare before and after, these were the graphs before repair, and you can see there was a huge impedance change out there at 3.7 kilometers. This is post repair, and you can clearly see that the impedance change is improved by 20 dB after repair. So again, you can see the efficacy of the repair, and you can quantify the cable condition. Okay, this particular joint, I'm getting 20 dB. That's my new baseline. I can now trend this over time to see, okay, how is it degrading? Uh, there was also some lab experiments done in the US, which I would like to showcase now to compare LIRA with the traditional TDR technology. So they took some cable samples and purposely created some defect, such as they smashed it with a hammer, they did an extreme bend on the location and made a special splice on the cable. You can see the TDR graph of before and after, and the changes in the TDR are practically invisible. However, LIRA was performed, it was very easily able to pick up uh, each of these three defects without any issue. I can kind of also show you that the traditional time domain reflectory methods have they've been good, but they have serious limitations, and FDR with LIRA is the way to go. This is just one more case where the jacket was purposely cut, and again the jacket cut could be detected with LIRA, and TDR showed no signs. Just to close up now, just wanted to introduce the next generation, which is the Viascan digital ecosystem or solution. Of course, you have the traditional LIRA 1 methodology where you do offline testing of your cables, but now you also have a new development, the LIRA Live system, wherein we can permanently install these sensors on your cables, and these can assess the condition of your cable in real time. And taking that forward to the next step is the Viascan digital platform. Here what happens is this will collect the data from your online measurements, you can incorporate your offline measurements, you can also amalgamate your other data like tan delta measurements, partial discharge measurements, DTS values, and the Viascan digital system, which is provided as a service, it will assess the integrity of your cable based on all of these parameters and give you a real-time indication about the health of all your assets. So to sum it up, you've got unique cable diagnostics. You can pick up physical damages, stresses. It's the only methodology that's available that can pinpoint the location of the water trees. It can pick up multiple cable defects. It's a low voltage method, so there's no risk of damaging any cable, and it really works on extremely long length cables. I've tested cables up to 14 kilometers in length. Wirescan has done cables which are more than 100 kilometers in length and done that very successfully. What does that give you? It basically enables you to do cable risk management and gives you control over both your CapEx and your OpEx. Because you've got online monitoring, you can look at just the trends that's happening in your cable. If you have incipient defects, you can plan your downtime and carry out repairs and maintenance in a very short period. And if you do have a situation where your cables fail, you can very quickly know where the location is, and that reduces your downtime. So folks, that's all I wanted to present about LIRA. I'll be happy to take any questions you have in the Q&A session. Thank you very much.